Assume that over 12 kilometers from port, a sailboat encounters rough weather and is blown off course by 16-knot wind. Here is, you can see on the picture. So look where the port is, right? And this is, look where the sailor is. So how can the sailor indicate his location to the Coast Guard? This is what we're gonna learn, the polar coordinate system, because sailors use the polar coordinate system, as well as pilots use polar coordinate system when they fly airplanes. Okay? So let's explore, let's understand what polar coordinates are. So far we have used to work in the rectangular coordinate system, where we can address any object by pointing x and y of the object, right? Which is address of the object. Okay. So to form the polar coordinate system in the plane, what we are going to do, we are going to take the point 0, or O rather saying, and we call it as a pole. Okay, or origin also we can call, and construct from point O an initial ray, okay, which we call polar axis. Polar axis. Okay, then in this case, any point in this system, let's say if I take point P, okay, how are we gonna address it? This point P in the plane can be assigned polar coordinate, okay, in the following way. It's gonna be r, which is directed distance from O to P, or we can call it also radius. That distance is connected to pole. Okay, so this is our r distance, and it's directed distance, and theta is going to be our directed angle. Directed angle. And r is directed distance. Directed distance. Okay. So those r and theta we call polar coordinates. Okay? Just like x and y, we call rectangular coordinate. Okay? Now, let's look at the following picture here. So this picture shows 3 points on the polar coordinate system. As you noticed that in this system, it is convenient to locate points with respect to a grid of concentric circles intersected by radial lines through the pole, right? Through the pole. Okay, with rectangular coordinate, each point xy has a unique representation, right? But this is not the case with the polar coordinate. For instance, the coordinate r theta and r plus, hold on, let me, r comma 2 pi plus theta represent the same point. If you look at the this picture and then this picture, because look here, we have here theta is equal negative pi over 6. So if I do theta plus 2 pi, right, make full circle, and it's gonna come to the same position. So negative pi over 6 plus 2 pi. This is gonna be equal negative 1 over 6 pi plus 2 pi. It's gonna be 2 minus 1, 6. It's gonna be 1 and 5 over 6 pi. So if I convert into improper fraction, I'm getting 11 pi over 6. And here we go. So, and negative pi over 6 and positive 11 pi over 6 have the same position, right? Okay. Now, also, because r is in directed distance, then the coordinates like r, let me use this, r theta and negative r theta plus pi represent the same point, right? Because it's a negative r, and if you add theta plus 1 pi, so it's gonna flip to the opposite direction, correct? So therefore, in general form, the point r and theta can be represented in the general form. R and theta coordinates can be represented as r and theta plus 2 pi n, right? Or we can write down r theta is equal negative r theta plus 2 pi plus 1 times pi. This is just in case if we have odd period, okay? So this one for even period, this one for odd period. And how can we address pole itself, which is center, right? So we are going to address by r, right? Say pole. We're going to address again, just like any other object in the polar system of coordinate. So it's r and theta, which is going to be equal. Distance is going to be 0, right? Because it's the pole itself. There is no distance. And theta can be any angle. Or rather saying, I would rather say it's undefined because it can be anything, any angle. Okay? Now let's establish relationship between polar and rectangular coordinate, because they can't coexist separately. If we have two different coordinate, there has to be some way to convert one system to another. Otherwise, it will complicate our life much more if there wouldn't be connection between them. So we are going to now to establish relationship between these two coordinates. All right. So let the polar axis coincide with the positive x axis. Let me see. Let me draw first, and then I'll start talking. All right. Okay. Okay, so let me write down, this is what we have. This is our pole, right, beginning. This is our r, distance, directed distance. This is a coordinate r and theta in polar system, and x and y in rectangular coordinate system. So the r and theta, here we have theta, and let me change this color so we will know it's rectangular. And here we have y, and this is our x, right? And this is our polar axis, polar x-axis. Okay? All right. So because xy coordinate lays on the circle of radius r, then it follows, so r squared is equal x squared plus y squared. So let me do better reasoning for this. So this y is a perpendicular to our x-axis, right? Which means it creates rectangle with the right angle. And using Pythagorean theorem, we can say that square of hypotenuse is equal sum of squares of legs, correct? So besides of that, moreover, for r is greater than 0, the definition of the trigonometric function, it's gonna be, I can write down the tangent theta is equal opposite leg, which is y, over adjacent leg, which is x. Cosine theta is equal adjacent leg to hypotenuse. Sine theta is equal opposite leg to hypotenuse. Okay, so from here we can establish relationship that will be expressed as follows. X is equal r times cosine theta, and y is equal r times sine theta. So here we got our polar to rectangular conversion relationship. Now, for the case of r is less than 0, r is less than 0, and theta is measured in radians, okay, then the point P that has coordinates r and theta can be represented as negative r pi plus theta, where negative r is greater than 0. Okay? And since cosine pi plus theta is equal negative cosine theta, right? All right? It's equal because cosine is a even function, correct? Unlike sine is odd function. Then we can say it's equal x over negative r. And sine pi plus theta is equal negative sine theta, which is going to be equal x over negative r. Okay? So, and this way we have x is equal r times cosine theta, and y is equal r times sine theta. And we got it from here, right? Negative cosine theta equal x over negative r, negative sine theta equal x over negative r. So x is equal negative cosine times negative r, and y, okay, y is equal negative r times negative sine theta. Okay, so this we established here polar to rectangular coordinate. Polar to rectangular. Okay? When I'm in a hurry and I put my writing is okay. So from polar to rectangular conversion, we have x is equal r cosine theta and y is equal r sine theta. And for rectangular to polar conversion, rectangular to polar conversion, we had here, where is it? Yeah, here it is. R squared is equal x squared plus y squared. See, x and y, it's a rectangular coordinate. R is a polar coordinate. And tangent also here, tangent theta equal y over x. It's going to be the conversion for angle. So we have here and the directed distance and angle theta. Okay? So tangent theta is equal y over x, and r squared is equal x squared plus y squared. Okay, so for rectangular to polar, Here from polar to rectangular, we figured out x and y, and from rectangular to polar, we figured out theta and r squared. Since if we find tangent theta, then theta is going to be arctangent theta, right? We will do it in next video when I will start solve some practicing problem. We will do some conversion and do some application solving on this topic. I like this topic, it's very interesting. Hopefully you enjoy it also. Okay, okie dokie.